Hey everyone, welcome to my channel. In this video, we are going to run OCR with OpenCV. So let me show you what we will be doing and what will be the final result. So here I have the blog about this project, which I haven't completed yet, but soon I will, and I will post this as well. So the idea here is that we have this awesomeness form that you have to register to be awesome, right? So you have to give in your name, your phone number, you have to acknowledge that I am awesome and you cannot deny. And so the idea behind this was that you should be able to work with input text and input as a checkbox. So here we have input text where we have name, phone number, awesome ID and stuff like this. And then we also have the checkbox. So here we will be able to detect whether they have checked it or not. So we will be using feature detection to actually align the images. So here you can see that we are detecting all the features and we are matching them. And then here are some of the filled forms that, for example, are our input. And then we are going to extract the form first and we are going to align so that it becomes as the original shape. So by that I mean like this. So all of these are basically aligned and now they are with a bird's eye view. And the thing is that I did this in one of the previous videos where you had to have all of the region of your form within the actual image. But in this case, we don't have to. You can see on the right hand side and on the left hand side, this is a more advanced technique that does not require all of the form to be in the picture. So you can see that wherever it's missing, it will put this black area and it will still work. So it's much more reliable and robust. And once we have that, we will extract all this information. You can see that we have the name, the number. Let me show you here. So the name, the number, the contacts, and the ID, and of course the country and the city. And yes, I am from Mars. That is true story. Then we will display the results. We will overlay it on the original image. And you can see here we have Sarah, we have the phone number, we have 1 if it's checked, 0 if it's not checked, and then we have all of the other information as well. And at the end of the day, we will extract all this information in form of text, and we can also put that in a document. So we will save all of it in a file, in a CSV file, and that CSV file we can open with, let's say, Excel. And the conclusion is empty. As I said, I'm still writing the blog, so I will put this as well so that once you're done with the video and you want to get to some very specific area of the video, then rather than going through the whole video, you can come to the blog and check out the specific topic. Okay, so this was the introduction. This was what we are going to do. So let's dive in straight away and get started with this project. It's very exciting. It's very useful. So without further ado, let's get started. Okay, so here we are in the PyCharm environment and all of the packages that we need are pretty much available here and we can install them in the settings. But one of them needs an external installation and that is PyTesseract. So this is basically the Tesseract documentation. If you are not familiar with Tesseract, it is one of the most popular library for text recognition, which is OCR, optical character recognition. And the reason it's quite popular is because it's free and it's very reliable when it comes to printed fonts. So here we are going to use the Windows version and we can install for Windows over here. I will put this link in the description or on my website where you can download this. After the installation is complete, you will go to Program, Files in C, and then Tesseract OCR. So over here we need is the Tesseract exe. So basically this is the file that we will link to. So just remember this, we are going to copy this and we will paste it here. We can comment it out for now and later we can use this. So first we are going to go to File, then Settings, and over here we are going to add all the libraries. So what we need is the OpenCV, Python, and I have already installed all of these, so it's showing blue. Otherwise you would click here and click install. Then we need numpy, and then we need pytesseract. Yeah, there you go, pytesseract, and you will install all of these, and then we will hit OK and we will come back here. So we are going to import cv2, and then we will import numpy as np, and then we will import pytesseract, and then we will need import os for the directories. So then we are going to link our file, the one that we were mentioning. So we are going to write pytesseract.pytesseract.tesseractcmd equals, then we are going to add this link over here, this path, and then instead of slash we are going to write double backslash, so backslash. Okay, so here we are going to write this, and we will write here tesseract. I hope the spellings are right, tesseract.exe. Then we are going to import our image. Now before we do that, let me show you the files that we have. So in OCR forms, this is our project. We have the user forms and we have the original forms. So original forms we are not interested in. These are the ones that are already filled. But this is the actual image. We don't want that. What we need are the test images. The images that I have taken from my mobile phone. So these are the images that we are going to detect our text from, and then we have the query image. The query image is the blank form that we will be using as our template to find it in our test images. So we need to import this first. So we will write cv2.imread, and we are going to import our query image, which is query.png, and we are going to save it in imgq, which will be our query image. Then to display this, we can write cv2.imshow, and we can write this as output, and then we can write imq, and then cv2.waitKey, and then we will write 1, or no, let's write 0 for now, because later on when we loop we can add a delay of 1 or whatever we need. Okay, so let's run this and see if we run into any errors, and we don't. So here is our original image. So we are going to print this out quite often, so we need to scale this down just for the viewing purpose. So we can write here that image_q is equals to cv2.resize, and we can write image_q, and then we can write no, we need to write a bracket, then we will write width, or let's just write w divided by 2, or let's write 3, and h divided by 3. But what are these w and h? These are the width and height of our image, which we can get from height, width, and channel. We can write image_q, and then we can write shape. So that should work. Let's run that, and there you go. So now we have a much smaller image that we can look at. But again, at the end of the day, we can remove this, and it will give you better results. Next, we are going to create our detector, which will be ORB. Now we are using ORB because it's free to use. The other ones like SIFT and SURF, they are not free to use. You have to get a license and stuff like that. So we are going to simply use ORB is equals to cv2.orb create. I have done another tutorial in which I have explained furthermore what is basically ORB and what are these features. So you can have a look at that if you want to go into more details. So inside this, we only have to define the features. So by default, it's 500. We can put, let's say, 1000. And later we can see how that affects our features. Okay, then we will write p.1, which is basically our key points, and then we will write the descriptors is equals to key points are the unique points or unique elements to your image, and then the descriptors are the representation of these key points that will be easier for the computer to understand and differentiate between. So we are going to write here that orb dot detect and compute. Oh, this is supposed to be a dot, and then we are going to write image q, and we will write the mask as none. Okay, should we let's view this so that it's easier for us to understand what is going on. So we can write here that our image, let's say kp1, our key points are cv2.draw key points, and we will send in our image, which is image q, and okay, write this, and then we are going to write kp1 as our key point, and then we don't have an output image, so we will write none because we are storing it here. Then we can simply display this. Let's just copy this and paste it here, and then we can write kp1 over here, and let's run this. Oh, I didn't change the name, so we have to write here key points for the query image. And there we have it. So now you can see these are the key points that we are getting from our query image. So okay, let me show you what happens if I put this as 5000. There you go. So earlier you saw that it was not detecting any key points below, but now it's detecting key points everywhere. But the thing is that we don't need these this many key points to actually find the matrix, the transformation matrix for the image. So we can simply write 1000, and that should be enough. If it's not, we can change it later on. Okay, so we can remove this, and we can remove this because we don't want to display that any further. So next we are going to bring in all these images so that we can find the features of these images, and then we can compare it with our features of this query image. So we will write here, first of all, path is equals to the name of our folder, which is user forms, and then we will find out the list of our images. So my pick list, let's say, is equals to os.list directory, and then we will give in our path. So let's print this out and see what happens. So here you can see that we have the list of names of all our images. So we have test3.jpg, test2, test1. So we can use this information to actually import all of these images. So to do that, we can write here, we can loop, and we can say that for, let's say, j and y in enumerate, we are going to write my pick list. So we are writing enumerate because we want the index value as well. We want to know how many times the loop has run. So the actual value of my pick list will be in y, each item one by one. So we are going to find that. So we can write that image is equals to cv2.imread, and then we will write our path, then the path plus our slash, and then plus our y. So this will be the complete path to our image so that we can find and import it. So then we can simply find the detector for this, or should we, let's view it first so that we are sure that it's working. So here we are going to put it down, and we will write here image, and we will write here y because that will be a unique name every time. So we will view each of these, and this says 0. I think it will work. Let's see. If it doesn't, we can change. yeah, it works. So again, these images are huge, so we can scale them down. Let's copy this part and we will write it here, and instead of image q we will write image, and let's rerun, and there we have it. So these are our images that we are getting, so all of them are importing properly. Okay, so that is good. They are a little bit squeezed. I think that's why it's looking a little bit weird, but it should be fine. Okay, so now we can comment this out again, and then we can find the descriptors. So we will write here kp2 and then descriptor 2 is equals to, we will write here again the same thing. We will compute, and this time around we will compute using our image. So let's, we don't need to see the key points for it, but what would be interesting to see is the matching of it. So we can view that later on. So to find the matching, we have to use a matcher. So we will write bf, which is our brute force. So we will write cv2.bf matcher, which is our brute force matcher, and we will use the cv2.norm underscore Hamming. So you can read the details of this in its documentation, and so for now we are just going to use the match. So let's say match is equals to bf dot match, and then we will write descriptor 2 and then descriptor 1. So it will match these, and let's write it matches, and this will give us all the matches. So what we can do is we can print it out and see how the matching is working at the back end. So we can write here, let's say, should we print this out? Okay, let's sort it out first. We are going to sort out all the good matches. So we will take only the good matches, and then we will display it, and then we will use it later on. So we are going to write that matches dot sort. We are going to sort them out, and we are going to use the key is equals to lambda, and we will write x and then x dot distance. So basically all this does is lambda is a single line function. What it does is it allows us to map basically or sort all of the matches values based on the distance. So the lower the distance, the better the match is. So we will have all the good matches at the very beginning and all the bad matches at the very end. So now all we can do is we can extract how many matches do we need, how many good matches do we need. So we can write here good, and then we can write matches, and we can extract, for example, we can say we need from the very start till, let's say, 20 matches, okay? Or we can write 50 matches, something like that. So but what I want to do is I want to put a percentage. So we can write here that we have the length of matches. So however many matches we got, we will multiply it with a percentage. So we will say multiplied by percentage divided by 100, and then we are going to make this an integer so that we don't have decimal places. So that will give us a number, and what we can do is we can write here, let's say here percentage, and we can say that we need 25%. Okay, so that should give us 25% of the best matches. Okay, so once we have these matches, we can draw them. So we can write here image match is equals to cv2 dot draw matches, and we are going to give, what is this? Okay, we are going to give our image, and then we have kp2, then we have our image query, and then we have kp1, then we have all the good matches, and then we have the out image, we don't want any, and then we have the flag. We will put the flag as 2. Okay, so then we are going to display this. So we will write here. Okay, let's just copy this, and we can remove this part and we can write this. Okay, and let's remove it from here, and this will be basically y again, and this will be image match. So let's run this and see what happens. Okay, so now we can see some interesting results. So there you go. So now you can see all the matches that we are getting. Actually, it's drawing all of the matches. Is it? I think we have a lot, that's why it seems quite a bit. But it is drawing. Let's say that we only want the, let's say, 20 best matches. Okay, so now you can see these are the best matches, and you can see that it's not that bad. It is able to detect. Here it's really bad, it's detecting this, and then we have it here. So again, if we put, let's say, 100, this is, by the way, only for displaying purpose, and we can see that we have a good amount of matches at the top. And this is what we saw in the very beginning, that it was detecting all the key points at the very top. It was detecting it over here where we have text extraction and OCR tutorial, so it was detecting here. And the other thing is that when we remove this, it will actually give us a better result. So yeah, so what we can do is we can copy this, and just before it's about to display, we can resize only the img match, so that will give us a better result. And there we have it. So now you can see it's a little bit harder to see now what happened there. So it's a little bit harder to see now because the scale, we have scaled it down, but you can still see that most of them are still at the upper area of your form, and that is because we saw all of the key points being detected there. Okay, so the next step is to find all the source points and the destination points so that we can find the relationship between these two. So the relationship between the query image and the test image. So once we have that relationship, which is basically our matrix, then we can align the image based on that matrix. So we will write here that our source points, so we will write src points is equals to numpy.float, and we will write 32, and inside that we are going to write that we need kp2. So we are basically writing a list comprehension, so we will write kp2 at m.query query id index. We are going to get the point for m in good. So basically we are getting all the points within our good list, and then we are finding the actual points of them. Then we will reshape this, reshape to -1, 1 and 2. This is something that you have to do to make it work. Not much intuition there. Okay, so we will copy this, and here we will write destination, so dst, and here we will write kp1, and then we will write train, and that should be it. So now that we have both of these, we can find the matrix M, and the second output or the second result we don't need. So we can write here cv2 dot find homography. So basically finding this relationship is called homography. So we will write that our source points, source points, and then we have our destination points, and then we have the cv2.ransack that we will be using, and then we have 5.0. This is our parameters. So these parameters I have taken from the documentation, so we are going to keep them default. So now we can use this matrix to actually align our form. So to do that, we will write image scan is equals to cv2.warp perspective, and then we will write image and then the matrix M, and then we have to give the width and the height, which we already have, which are W and H, and that should be enough. So let's remove this from here, or let's just comment this one out and copy it, and let's paste it here, and then we can write image scan. So let's see if that works. Okay, I forgot to rescale it. So here, let's remove this here and bring it here, and we will do it for the image scan. And there we have it. So now you can see that all of our images, they were, let me show you. So let's say this was our image before, and now it is like this. This is what this is. I think the first one, yeah, this is this one. So initially our image was like this, and now we have it like this with the bird's eye view. So the next step is basically that we are going to extract these regions of interest, and then we are going to send it to our PyTesseract, and then we will find whether the checkbox is ticked or not. So all of this we will do in the next video, and we will see what kind of techniques we can use to actually extract our information and then save it to a file. So stay tuned for that, and if you like this video, give it a thumbs up, and I will see you in the next one.